Two questions on ohmic circuits have been frequenting my desk. Both of them are coming from some past exam papers and want to dissect them today. So let's quickly get into ohmic circuits as we break down these questions. Enjoy your time. So this is one of the questions which is prominent on my desk across the globe. It's coming from the 2023 to 2025 specimen, and it's question number 8, and it's dealing with ohmic circuits. So I'm just going to demonstrate how to negotiate this question, what is expected of you, and how to do nodal analysis when you have a parallel circuit like this. And this is a composite circuit as we are looking at it. The 8 ohm resistor and the 4 ohm resistor are in series, but both of them are in parallel with the 6 ohm resistor at the base. So we are going to break down and calculate the combined resistance between Y and Z. Now the first thing is, if we want to find the combined resistance in a composite circuit, we analyze it branch by branch. So you can see that from point Y, there is the top branch, which has two resistors. Those two resistors are in series. The 8 ohm resistor and the 4 ohm resistor are in series. However, they are in parallel with the branch B, which is a 6 ohm resistor. So in order for us to find the total resistance or the effective resistance in the circuit, we need to first resolve branches. So let's start by dealing with branch number 1. Branch number 1 has two resistors in series. R1 and R2 are in series. And when resolving resistors in series, we remember that for resistors in series, the total resistance is R1 plus R2 plus until we add Rn. So we are just going to add the two resistors, 8 plus 4. That's how we are getting our 12 over here. Now we deal with branch 2. Branch 2 is very easy. There is only a single resistor, so the effective resistance across that branch remains 6 ohms, which is equivalent to the resistance of the resistor along that branch. Now the next thing we want to do is to combine these two branches. Now if we look at it carefully, we will see that branch 1 is parallel to branch 2. And for resistors in parallel, if there are two, you are free to say the effective resistance is product divided by sum, which is R1, R2 over R1 plus R2. This is only true for two resistors in parallel. If there are 3 or more, we revert to the sum of reciprocals. In other words, we'll be saying 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Now in this case, we have a privilege of having two resistors, so we can use product over sum, and we come up with an expression which says product over sum the resistor on branch 1 times resistance on branch 2 divided by resistance on branch 1 plus resistance on branch 2. So we now have the effective resistance for branch 1 is 12 and that for branch 2 is 6. So we do 12 plus 6, sorry, 12 times 6 and 12 plus 6. That's how we get our 72 divided by 18. And consequently, from the calculators, we should get the effective resistance in that circuit to be 4 ohms. Now, the question which dominated across on my desk is part B. Calculate the potential difference across the 8 ohm resistor. Now, we should know some key rules when dealing with circuits, ohmic circuits. Number one, in series circuits, current is not divided, but voltage is divided. Consequently, the current flowing through the 8 ohm resistor is the same as the current flowing through the 4 ohm resistor. Why? They are in series and current is not divided. But the voltage across the 8 ohm resistor is different from the voltage across the 4 ohm resistor. Why? They are in series, their voltage is divided. Voltage is used according to the requirements of the component, according to resistance. The greater the resistance, the greater the voltage across that component. Now, for parallel circuits, voltage is not divided, but current is divided. In other words, if current is flowing in this direction, when it reaches the node Z, in other words, when it reaches the junction Z, some current will go downwards, while some current is going upwards. So current is divided. It reaches the node, it divides. But the voltage is not divided. In other words, the voltage across branch 1, is equal to the voltage across branch 2. No matter the resistances, voltage is not divided. Voltage across branch 1 is equal to voltage across branch 2. This is the rule for parallel circuits. In other words, we can say the voltage across branch 1 is 24 volts. The voltage across branch 2 is 24 volts. The voltage of the branches is equivalent to the voltage of the source. Now, having that in mind, the voltage across the entire branch B is 24. But the voltage across the 8 ohm resistor is different from the voltage across the 4 ohm resistor. Voltage is divided. Now, the resistor with a bigger resistance will take a bigger fraction. In other words, the 8 ohm resistor of the total in that branch, it will take the bigger portion of voltage. The greater the resistance, the greater the voltage across that component. So the 24 volts across the branch 1, since it takes the voltage of the source, will be divided in such a way that the resistor R8 resistance will take a bigger portion, which is 8 of the 12. Because if we say 8 plus 4 in that branch, we are getting 12. So 8 of the 12 portions will be allocated for the 8 ohm resistor. How much voltage is divided across that branch? We have seen that there is 24 volts. So we are going to say 8 divided by 12 times 24, and we'll find that the resistance in that across that resistor is 16 volts. Right, so this is one question. You can find the question in the IGCSE specimen paper, the 2023 to 2025 specimen paper, and it's on question number 8, and that's how you are supposed to deal with it. I hope I've addressed all those questions which were coming to my desk. Now, there is another question which is coming from ECZ. This question involves in ohmic circuits again. So let's quickly look into that question. Then I'll leave you with one for practice also. I just enjoyed it myself. It's from ECZ. I'll give you, and I'll come with the answer some other time, but not today. Right. So here is a circuit which is coming from the Science Paper 1, 2016, Examination Council of Zambia. And it was question 7 in section B. Now, we are given another parallel circuit where there are 2 resistors, and we are required to calculate the effective resistance. Like I said before, if you have more than 3 resistors, we go to our equation 1 divided by R1, R total is equals to 1 over R1 plus 1 over R2. You keep adding until you reach 1 over Rn. But if you have two resistors, like in our case, across A and B, we can safely say the total resistance is the product R1, R2 over R1 plus R2. We call it product over sum. Consequently, we are free to say the effective resistance across A and B, since there are two branches, we will say product over sum, the resistance across branch 1 times the resistance across branch 2 divided by the resistance across branch 1 plus the resistance across branch 2, which is 4 for branch 1, 12 for branch 2. So 4 times 12 divided by 4 plus 12, we get 48 divided by 16. Consequently, after punching the calculator, we're going to get 3 ohms. Right, part B required us to calculate the value of the current in the 4 ohm resistor. So let's recall and bring back our circuit. This question is interested in the current across the 4 ohm resistor. So we want I on branch number 1. Now we go back to the simple rules. Voltage is the same as the source voltage if all branches are in parallel. In other words, here we have 6 volts. Here we also have 6 volts. The voltage of the source is the voltage of the resistor if they're in parallel. All of them are in parallel. Voltage is not divided. However, current is divided. In other words, taking the conventional direction of current, current will flow and reach junction A. Some will go on the upper side, some will go on the lower side. So current is divided in parallel circuit. But if we recall Ohm's law says V is equal to I, R. Do we have V? The source voltage is the voltage for each branch. Do we have R? We have 4 ohm resistance for this part of the question. So we are looking for I. So we can make I subject to formula by dividing both sides by R. So we can find R without using ratios. Consequently, we recall Ohm's law. I is V over R after making the subject formula according to this process. What is the voltage on that branch? It's 6 volts. Why? Voltage is not divided. The source voltage is the same as the branch voltages. On that branch, the resistance is 4 ohms. So we now have 6 divided by 4, and we are going to get 1.5 amps. So this question for science takers, ECZ, it was not a very challenging question. Right, part B required the voltage across the battery. Now this question is the same as calculate the voltage, the total current in the circuit. Why? The voltage across the battery, the current across the battery is the same current which is flowing before the current divides. Current passes through, this is the total current. It only divides at A, it joins at B, it joins again. So the current passing through the battery is the total current in the circuit. So we recall total current in a circuit is voltage total divided by the total resistance in the circuit. We recall that equation. The total current, why are we saying total current? The current flowing through the battery is equivalent to the total current because current has not yet divided. What is the total voltage? 6 volts from the battery. What is the total resistance? From the previous question, we found our effective resistance as product over sum 4 by 12 divided by 4 plus 12. That's how we got our 3. So our effective resistance in the circuit is 3. We do 6 divided by 3 and we are going to get 2. Now, the last part of the question was, would the addition of an extra resistor between A and B in parallel with the original resistors increase decrease or decrease the current in the battery? Explain your answer. Now, I'll state the answer and then I'll explain. Number one, you should know that the addition of a resistor in parallel systems is always going to increase the current flowing in that circuit. I'll give you as a rule. The addition of a resistor in a parallel system will increase the current flowing. Why is it so? When you add a resistor, you reduce the effective resistance, because we know that in parallel system, RT is 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So we are adding reciprocals. So adding another resistor, it's adding another reciprocal 1 over Rn, which reduces the effective resistance. And when the resistance is low, current is very high. Why? Ohm's law says V over R is equal to I. So we can see that current and resistance are inversely proportional in ohmic circuits. Hence, once your resistance decreases, your current increases. I will leave you with this question just for your practice. I'll come with the answer sometime when we find more space. As of now, your senior coach is checking out. See you in the next review.